Hello friends, today we shall be learning about Euclid's geometry. This is chapter for class 9th. Now, Euclid was a famous mathematician who collected all the known work and arranged them in his famous treatise called Elements. Now, he divided elements into 13 chapters. These elements included three main components, namely definitions, axioms and postulates. Now, let us understand the various definitions given by Euclid. First definition is, a point is that which has no part. Second, a line is a breadth less length. There is no breadth to this length. Now, the ends of a line are always points. We can say that line is basically a group or a bunch of many points made together. Now, a straight line is a line which lies evenly with the points on itself. A surface is that which has length and breadth only. The edges of a surface are lines. For example, a cube or a cuboid. All these figures are solid figures and are made on surfaces having edges. Now, a plane surface is a surface which lies evenly with the straight lines on itself. What are axioms? Axioms are the basic facts which are taken as granted without any proof. The 7 axioms given by Euclid are: things which are equal to the same things are equal to one another. If equals are added to equals, then wholes are also equal. If equals are subtracted from equals, then the remainders are always equal. Now, things which coincide with one another are always equal to one another. Next is, the whole is greater than a part. Things which are double of the same things are equal to one another. And lastly, things which are halves of the same things are also equal to one another. Now let us understand these axioms in detail. First axiom, things which are equal to the same things are equal to one another. For example, if you take two values A and B and suppose A is equal to B and B is equal to C, then A is also equal to C. This property is called transitivity property in mathematics, which you will be learning in higher classes. Now, the meaning of axiom 1 is, if anything is equal to something, it is equal to another thing, then the two things are equal. Here in this example, we have taken A is equal to B and B is equal to C. Therefore, A is equal to B is equal to C. Now, moving further to axiom 2. If equals are added to equals, then the wholes are equal. For example, if A is equal to X and B is equal to Y, then adding these two equations, we get A plus B is equal to X plus Y. Or we can also say that A plus Y is equal to X plus B, because A is equal to X and B is equal to Y. Now, axiom 3. If equals are subtracted from equals, then remainders are always equal. Similarly, just like axiom 2, taking example as A is equal to X and B is equal to Y, then A minus B is equal to X minus Y. Now, axiom 4. This is an important axiom. Things which coincide with one another are equal to one another. That is, if two things are identical, then they are always equal. For example, in this figure, we consider various triangles which are identical. A, B, C, D, E, F are all triangles which are absolutely identical in shape and size. Now, when they are stacked up vertically, then we get a similar figure, as you can see on the board. Now here you have a height and all the triangles are clubbed or piled up together so as to get a final shape which have all congruent or identical triangles put together. This is also a scenario when you try to understand how a cylinder is made. A cylinder is nothing but various circles of same radius piled vertically upwards. Therefore, you get a cylinder of height, say h. Now, that is also an example of how two things are identical when they are put together and are also equal. Now axiom 5. The whole is greater than a part. To understand this, consider this figure. When you consider having a pizza at a restaurant, you get a circular shaped pizza, and one triangle of that pizza is obviously less than whole of the pizza, because whole pizza consists of say 6 or maybe 8 triangles, but one triangle is always less than 8 triangles put together in a circle. Therefore axiom 5 is all about whole is greater than a part. Now axiom 6. Things which are double of the same things are equal to one another. Now for example, consider x is equal to y. Then x plus x is equal to y plus y. The axiom which we have done in previous slide, that is, if a is equal to x and b is equal to y, then a plus b is equal to x plus y. So here, instead of taking a and b differently, I have just taken x is equal to y. So now when you add this equation twice, what do you get? X plus x is equal to y plus y. Therefore 2x is equal to 2y. This is exactly what axiom 6 is all about. Things which are double of the same things are equal to one another. Or we can say that if 2x is equal to 2y, then x is equal to y. Axiom, the next one, that is x minus y is equal to a minus b. Yes. So if 2x is equal to 2y, then you have x plus x is equal to y plus y. Therefore, subtracting x and y from both sides, because x is equal to y, what do you get? X plus x minus x is equal to y plus y minus y. Therefore, x is equal to y, because one x and x cancels out. Okay. Now, axiom 7. Things which are halves of the same things are equal to the same thing. Now, if half of x is equal to half of y, then you can say that x is equal to y. You can simply cross multiply 1 by 2 and 1 by 2. That is, you take the 2 in the denominator to the next side of the equal to sign, and therefore you 2 and 2 cancels out and you get x is equal to y. Let us move further and understand what are postulates. Postulates are axioms related to a particular field. The various postulates given by Euclid shall be discussed now. First postulate. A line segment can be drawn joining any 2 points. Suppose A and B are 2 points. Then to join them, you simply form a line making A and B as the endpoints. Therefore, a line segment can be drawn joining any 2 given points. Second postulate. Any line segment can be extended indefinitely to form a line. This is exactly the definition of a line. CD is a line segment, and when you extend this on the both sides, you get a line. Okay. So given a line segment CD, you can extend it to make a line CD. This is postulate number 2. Now postulate 3. Given a line segment, a circle can be drawn having the line segment as a radius and one endpoint as a center. Suppose AB is a line segment. Taking A as the center and taking the radius to be AB, you can form a circle of radius AB. This is postulate 3. Postulate 4. All right angles are congruent. Now what is a right angle? A right angle is an angle measuring 90 degrees. Therefore, if you have an angle, say angle F as 90 degree, and here also in angle G is 90 degree. Therefore, these two angles are congruent because the measurement of these angles are same, which is 90 degrees. Now, postulate 5. If a straight line that meets two straight lines makes interior angles on the same side less than two right angles, then those two straight lines, if extended, will meet on the same side. Now please focus on this figure. Here PQ and MN are these two lines PQ and MN are two lines and having AB as the transversal. That is, this line AB meets these two lines at two distinct intersecting points. Okay. Therefore, when you consider making angles, you get 4 angles. Angle 1, 2, 3 and 4. Now, postulate 5 says that if a straight line, here in this figure, a straight line is AB, meets 2 straight lines, that is PQ and MN in the figure, makes the interior angles on the same side of the transversal, that is angle 1 and angle 2. See, angle 1 and angle 2 are called co-interior angles or angles on the same side of the transversal line AB. Okay? And the measure of angle 1 and 2 is less than 2 right angles. See, angle 1 is not 90 degrees. Similarly, angle 2 is also not 90 degrees. Right? So, these two angles are less than 2 right angles. Then those two straight lines, that is PQ and MN, when extended on the same side, will meet on that same side. That is, now if you extend MN and PQ towards more M and more P, see, extend the line PQ towards P and extend the line MN towards M. So you can see that at some distance these two lines will intersect. Okay, this is postulate 5. What is it? If the interior angles on the same side are less than 2 right angles, then those two straight lines, if extended, will meet on that same side. Here angle 1 plus angle 2 is less than 180 degrees. Therefore, these two lines, when extended towards point P and towards point M, you can see them intersecting at some point, say O. Okay, this is postulate 5. Postulate 6. If L is any line and P is any point not on L, then there exists exactly one line through point B that is parallel to L. Now, see this figure. Say L is a line, okay, and P is any point downwards. Okay, so now you can make only one line passing through the point P, which is also parallel to line L. Therefore, postulate 6 demands that the line which is parallel to one given line shall pass through only one given point. Now, what is the limitation of the previously discussed postulate? Postulate can only be true in a plane and cannot be applied on a curve. Now, Euclid has given this as a very important observation, that this postulate, which is if a line L is any line and P is any point not on L, then there exists exactly one line through P that is parallel to L. But this holds true only if it is a case of a plane and cannot be applied to a curve. For example, various curves such as a sphere or maybe a parallelogram, maybe a parabola, etc. In such curves, this postulate does not hold true. You will learn about it in non-Euclidean geometry, which is not a part of this coursework, but however, for just quick information and to make students more aware, this is there in your NCERT textbook on the last page of your chapter. Now, Euclid 5 postulates are: a straight line may be drawn from any one point to any other point. A terminated line can be produced indefinitely. A circle can be drawn without any center and any radius. All right angles are equal to one another, or we can say that they are congruent. If a straight line falling on two straight lines makes the interior angles on the same side of it taken together less than 2 right angles, that is 180 degrees, then the two straight lines meet on that same side on which the sum of angles is less than 2 right angles. We have discussed this. Now, what is a theorem? A theorem is a statement that requires a proof. Okay? For example, the sum of angles of a triangle is 180 degrees is a very famous and a common example of a theorem. The angles opposite to equal sides of a triangle are equal. Now, what is a corollary? A corollary is a result deduced from a theorem. For example, consider this question. In the following figure, the point Z lies between x and y such that xz is equal to zy or yz. Then, what is it? Work ABC is correct. If that is xz is equal to xy, or xz is equal to half of xy, or xy is equal to half of xz. Now, let us see the solution. Here, xz is equal to zy is given. Therefore, we can say that z is the middle point of the line segment xy, the line xy. Okay, so what can we write? Xy is equal to xz plus zy. Okay, now xz is equal to zy, which is given to us. Therefore, substituting the value of zy as xz, we can write xz plus xz. That is, we have simply put zy is equal to xz. So what do you get? xy is equal to 2 of xz. Now, taking 2 on the other side of the equal to sign, what do you get? xz is equal to half of xy. So which option is correct? xz is equal to half of xy. That is, B part is correct. Now, moving further, we need to prove that an equilateral triangle can be constructed at any given line segment. Now, consider a line segment of any measurement, say AB. Okay. Now, from postulate 3, we can draw a circle with center A and radius AB. Okay. So, what do you get? Because you get a circle of radius AB, so you get AB is equal to AC. Again, similarly, because AB is a line segment, now taking B as a center and radius BA, you can construct another circle. Okay. Now, when you draw this arc, you can see that these two arcs meet at a common point and mark it as C, such that you have BA is equal to BC, because radius is always equal in a circle. So what do you get? AC is equal to AB and BA is equal to BC. Now, because AB is equal to BA, therefore we can say that AB is equal to AC is equal to BC. Therefore, all three sides are equal and hence it is an equilateral triangle. That is, from Euclid's axiom, if two things are equal to a third thing, then the two things are also equal to each other. Therefore, AB is equal to BC is equal to CA. Now, this is a summary of the entire Euclid's geometry which we have discussed so far, and also on his book Elements. Have a quick glimpse of this flowchart. In the first, you have Euclid's geometry in the first circle, then you have his book Elements and Axioms, that is the general notions. Now, further, his book Elements have been subdivided into various categories, and then Euclid's axioms are also given as various subheads. Now, general assumptions specified to geometry are called postulates, and that's all we have discussed. Thank you so much for this, and this completes our Euclid's geometry chapter discussion. Thank you.